See here, general angular velocity can be defined as from this equation of relative velocity, angular velocity and a radius vector are related as v bar is omega bar cross r bar. From that part here, if you write omega is equal to perpendicular component of velocity by radius vector along the circular path. So here the perpendicular component of velocity vector for this angle between radius vector and velocity vector is theta. This is perpendicular component, and here the radius vector magnitude is r. So here if you multiply r and divide with r, then it is Vr sin theta by r square, and here Vr sin theta we can write it is as r cross v, r bar cross v bar is equal to rv sin theta upon r square. General form of angular velocity in terms of linear velocity and radius vector about an axis is given by, this is the formula, omega bar is equal to r bar cross v bar upon r square, or in magnitude mod of r bar cross v bar by r square. And see another small application. In calculating the relative angular velocity, we can write generally as well as omega 2 1 is equal to omega 2 minus omega 1 in vector form. Its magnitude is given by angular velocity is equal to the magnitude of velocity relative linear velocity vector normal to radius vector and its magnitude. Suppose two bodies are moving at 2 points with velocities v1 and v2, making an angle theta 1 theta 2 with radius vector. So here angular velocity, relative angular velocity of these 2 points in a circular path is given by v2 sin theta, they are opposite to each other, minus of minus v1 sin theta 1 by r. For same direction you can take it is v2 sin theta 2 minus v1 sin theta 1 by r. And here along this radius vector the relative velocity is v2 cos theta 1 minus v1 cos theta 2 r plus r minus is dr by dt. It is the linear velocity, or it is nothing but rate of change of relative position between the two points in the direction of radius vector. So thank you.